like I showed you in one of the previous examples, where we had the left one and the right one and the midpoint usually seems to be a better area representative than the left and the right, so it doesn't have to be. If we join the two endpoints and made a trapezoid, we have a probably even better estimate. So now we're going to go through the painful process one more time, but instead of using rectangles, we're going to use trapezoids. So we have to remember our area of a trapezoid formula. First of all, what is a trapezoid? A trapezoid has two parallel sides. We sometimes call one a base 1, one a base 2. And then it doesn't matter that the other sides are angled. Our rectangles that we're going to use used to be like this, right? This used to be our rectangles with lower sums, upper sums, left Riemann sums, right Riemann sums, midpoint Riemann sums. But now we're just going to say if one endpoint was here and the other endpoint was there, I'm going to have a trapezoid where these are my two parallel sides, so this will be base 1 and base 2, sort of turned on its side. You see it's the same shape, but now it's flipped on the side. And the area of a trapezoid is 1/2 b1 plus b2 times h. This is really actually easy to see as a formula, because every trapezoid with two parallel sides like this, you could split it here and get a rectangle in the middle and two triangles. And you know your area of your triangle is base times height divided by 2. So if we did the area of this trapezoid by breaking it up into shapes, this triangle would be base times height divided by 2. This triangle would be base times height divided by 2. And if you took the average of B1 and B2, so this length here and this length here, if you averaged it out, you could change half of this side. Can you see that if I took half of this part and flipped it up and put it over here, it would make a full rectangle. And half of this one and flipped it up and put it over there. So if I take the average of B1 and B2, which would go from here to there, it would make a perfect rectangle, and your area would just be length times width. In this case, length times the height. So that's all a trapezoid is recognizing a pattern with the triangles and getting it into a rectangle to find its area. But you can just memorize your formula. It's just average of your two bases. That's why it's 1/2 B1 plus B2 times by the height. So in our sums that we're going to do, we're going to take the average of B1 and B2 and multiply by the height, and the height in this case will be right there. Okay? Now the average between B1 and B2 is not necessarily, like you might be thinking, isn't that just the midpoint? Not quite. Doesn't have to be, because now you're averaging the y values, not averaging the midpoint. Average the x value. Trapezoid averages your y values to figure out your value. So here's an example of a curve with trapezoidal sums. You take every endpoint, draw a straight line to make a trapezoid, and would add them up. Okay? Notice you still have possibility for some quite big error, right? This little part at the end, between x5 and x6, there's quite a bit of error in that. But the trapezoid sum is just the average of the left Riemann sums and the right Riemann sums. Because the left Riemann sums always do the upper point, the right ones do it from the right side. In this case, it would be a lower rectangle. So if a question asks you to find a trapezoid sum, you have two options. You can either do each trapezoid, or you could do the left Riemann sum and the right Riemann sum and find its average. So let's just dive into a nice, crazy area question. A graph that you can visualize quite easily, sine x over x. And we're going to find the area from 1 to 2. So this part here that means the area under the curve. And remember that area under the curve was the area between the curve and the x-axis, with stuff above the x-axis positive, below the x-axis negative. 4 subintervals. So from 1 to 2, the distance is 1, so 4 subintervals would be 1/4. These are our 4 subintervals. So if we want to find a trapezoid, we can find the left Riemann sum using the left points, and the right Riemann sum using the right endpoints. And since finding rectangle areas is usually quicker than finding trapezoidal areas, this would be a technique that I'd recommend. Find the left Riemann sum, find the right Riemann sum, take the average, I'd like you to try one on your own on page 32. I will put up the answers there so you can check how your math is going. It's the left side, yeah. Oh. And the right side is always the right side. Yeah.
Mixing and matching.